Now we're going to look for the sine of pi over 12. Again, we'll try to find an exact value for this, not a decimal approximation. We may use the decimal approximation at the end to verify it, but for right now we want to try to get an exact value. We're going to radian angle measures rather than degrees, which makes it a little bit more difficult to find what we're adding and subtracting to get it. There's some strategies involved I'll try to share with you as we go. Pi over 12, it's just really a fraction of 1/12 times pi. The pi isn't quite as important there as the 12th. So think about the fraction 1/12. What fractions do we know that we could add or subtract to get 1/12? Well, 1/12 is a small value, relatively, and so probably subtraction is going to be helpful. Now we know things, we know angles of pi over 3 and pi over 4 and pi over 6, right? This is a 60, 45, and 30 degree angles respectively. I wrote those in reverse order, I don't know why, it doesn't matter, but so we're familiar with 1/3, 1/4, 1/6. So the question is, how can I add or subtract those to get 1/12? And again, maybe we ignore the pi's and just think of them as fractions, 1/3, 1/4, 1/6. Well, if I think of 1/12 as the difference of two other twelfths, you could think of it like 6/12 minus 5/12, right? That makes 1/12. Or 3/12 minus 2/12. There's a lot of different things that we could combine. And any of them, any combination will give us the same value when we simplify it. So, what do we want to use? We could do, 6/12 minus 5/12. 6/12 reduces to 1/2. We know pi over 2, but we don't know much about 5/12, right? So we're not going to use that one. We want to do something where we know some stuff about both of them. What about, let's see, that was 6 minus 5. What if we don't want to use 5. 5 doesn't work too well. Let's use 4 and 3, right? We could do 4/12 minus 3/12. That gives us 1/12. Well, 4/12 reduces to 1/3. 3/12 reduces to 1/4. So if you subtract pi over 3 and pi over 4, you get pi over 12. That's a good one. Let's try it. It's not the only option, but it will work. It's the first one we came up with, so let's go with it. So the sine of pi over 12 could be written as the sine of pi over 3 minus pi over 4, right? Because pi over 12 is the same as pi over 3 minus pi over 4. We just determined that. Okay, so that helps us out. Now we've got to figure out what these angles are. Well, we know pi over 3 is a 60 degree angle, and pi over 4 is a 45 degree angle. So when we start evaluating some of these things, we're going to need to use our special triangles to figure out those values, okay? Or your memory if you've memorized them. So this is the sine of a difference. Think of it as a minus b. Sine of a difference, we're going to utilize this formula. So a is pi over 3, b is pi over 4. Let's use the formula. We get the sine of a, which is pi over 3, times the cosine of b, which is pi over 4, minus the cosine of a, which is pi over 3, times the sine of b, which is pi over 4. Okay? So all I'm doing is I'm substituting pi over 3 for the a values, pi over 4 for the b values. Then I can evaluate each of those trig functions separately because we know those based on our special triangles. The pi over 4s are the 45 degree angles and the pi over 3s are 60. So the sine of 60, sine is opposite over adjacent, so it's root 3 over 2. The cosine of pi over 4, cosine is adjacent over hypotenuse, that's 1 over root 2. Or, you don't really want to do 1 over root 2, we want to rationalize that. And we've seen this before, it's root 2 over 2 when you rationalize. So let's use that. Square root 2 over 2 cosine of pi over 3. Well, that's cosine of 60 is adjacent over hypotenuse, that's 1/2. And the sine of pi over 4, sine of 45 is 1 over root 2, which again rationalizes to root 2 over 2. So we'll put in square root of 2 over 2. Okay, so now I have these two terms, each with two factors. I can combine those factors by multiplying the numerators and denominators together. So on top here I have a square root of 6, right? If they're both under a root, I can multiply them together, over 4, minus, here 1 times root 2 is just the square root of 2, 2 times 2 is 4 again, and because I have a common denominator, I can get those fractions together and just call that root 6 minus root 2 all over 4, okay? There's nothing else I can simplify. I can't factor out or reduce the numerator. It has no common factors with the denominator, so it's as simple as it gets. Now just to quickly verify, I could go to my calculator, get the decimal values, and show you that this will work out. Again, we are in radian mode, so when I go to my calculator, I've got to put this in radians, which I just did. Then we're going to type in the sine of pi over 12. Hit enter, and then I'm also going to put this in. Now when I put this in my calculator, I'm going to surround the numerator with parentheses. If you don't do that, you will get the wrong value and you'll think you'd messed up. But it's not that you messed up here, it's that you messed up on the calculator. So you've got to put the parentheses in. You want parenthesis root 6 minus root 2 parenthesis over 4. Okay? That's how you're going to need to write that in or type that in. So, parenthesis, root 6 minus root 2, parenthesis, divide by 4. And as you can see, right there, hopefully you can see that, the decimals come out to be the same. Okay, so, works out nicely. And that verifies that these two things are in fact equal to each other.